This is the second video in our AWS Developer Secure Application series. In this video we look at roles and STS credentials. AWS roles. When we create our new pristine account, other accounts or AWS services do not have any access to our resources. For any entity to access resources within our account, we need to explicitly grant access. For the specific situation where an external account is seeking access to a resource in another account, then there's only one way to provide that access, and that's via AWS IAM roles. To create a role, we must define a trust relationship. For AWS services, there exist service link roles that these services can use to access resources. A service or service link role creates a trust relationship for resources in your account that allows the service to assume the role and then access the resources or create the resources that the trust relationship establishes. We use roles for cross-account access. That is, we create a role with a trust relationship for a known external account. We limit the actions that these external entities can perform upon resources in our account by actions in our IAM permission policy files. We attach these permission policies to the role that the external entity will assume rather than attaching the permissions to the external entity. This is what it looks like when you're creating a role in a console. So if I was creating a role to allow an external account access, I would select the option you can see selected here. This is a very simple trust relationship for an IAM user in an account that I am granting the S3 service. This user in that account can assume this role, which will allow him to access the S3 service when I create this trust relationship. I would then attach policies to the role that would define what actions would be allowed on the S3 service for that account. This trust relationship defines an action STS assume role. Here, STS stands for Security Token Service, which is a well-known enterprise design pattern that uses an encryption scheme with a token that allows validation and digital signing of assets, in this case STS credentials, which, just like typical IAM credentials, allow us to create SDK clients. Unlike IAM user credentials, STS credentials are time limited. This has huge security benefits. An overview of how we create and use STS credentials and how all the bits and pieces fit together. Starting with an IAM user in an account with credentials. Using an STS client, they request a session. That session is based on a set of credentials and a token with a predetermined time to live. As long as the token is valid, we can use the STS credentials to build SDK clients to access AWS services. To facilitate the test, we will introduce a new application, IAM Manager, that's a wrapper around the AWS IAM SDK. We will use the IAM Manager in conjunction with the Crypto Manager to run an STS session test. We will create all the IAM entities involved with the IAM Manager. We will configure those entities with permissions with the IAM Manager. Once we've set up all the IAM entities, we will feed that data into Crypto Manager, which will run a test where it will create the STS session, create an Amazon S3 SDK client, do some S3 operations with the temporary STS credentials. We will first test everything against local stack, then we will run the test against AWS. Now we will run everything first against local stack, which we have set up here with IAM service S3 and STS, then against AWS. This is a Crypto Manager as before, but now we have a new tab for checking STS credentials flow. So we configure it just as before with a paraphrase, create this in-memory key store. We will configure this IAM Manager application just as we configured the S3 File Manager in the previous video. We log into the IAM Manager application with a paraphrase. This is the IAM Manager. We have two tabs, one for user and role-based operations, another tab for policy operations. We will go through the IAM Manager application in more detail in the next video. We will start by using IAM Manager to create a user, test user. Once we've created a user, we then move on to create a role. We need to give our role a friendly name and then select a trust policy. We will select a trust policy that we've set up for local stack. Once we've selected that policy file, we can create our role, displays the role on. Now we will go to the policy tab. We will select policy to deploy that is a managed policy for the permissions for our role. In this case, it's just listing buckets. So we need to deploy our selected policy. So there's our managed policy. As in roles, we give the policy a friendly name and a description before we deploy it. Once we've deployed the policies, we need to go to the Attach Policy tabs and attach the policy to the role. Now that we've deployed our policy, we need to go to our Attach Policies tab. You can see we have our remote policy, which we now can attach to our role. So we've attached our managed policy to our role. Now we want to use Crypto Manager to run the STS session test against local stack. To do that, we need to obtain our role arm. So we copy our role arm from IAM Manager and we paste this into the role arm for the session. Now we need to use the IAM Manager to obtain user credentials for our test user. So we've just created our credentials, which are encrypted. We now copy these encrypted credentials into the Create ST Session Check tab. We're entering our credentials now. So once we've got all this set up in Crypto Manager, we can create our STS session. So now we create our session, obtain our credentials. So we can make that a bit bigger so we can see we have credentials just like IAM credentials, only we have a session token and an expiration time. Now we've gone as far as we can against local stack. Now we're ready to run IAM Manager against AWS. We use Crypto Manager to set up and encrypt all the artifacts we need to log in with Cognito using IAM credentials for IAM Manager. So now we log into AWS with IAM Manager with Cognito using a paraphrase and Cognito password, everything stored in a password manager. Now we can see that IAM Manager is showing us all the IAM entities like service roles, user configured roles, and other IAM artifacts I have set up existing on AWS. So now we will repeat all the steps that we performed against local stack to create a test user, to create a role for that user to assume with a trust policy that's set up for AWS this time rather than local stack, deploy a managed policy to attach to the role to allow permissions actions for the S3 operations that we will run in our STS Credentials check in Crypto Manager. This is the AWS equivalent of a trust policy, so now we set it up to use the AWS account ID rather than the local stack default account ID. This is the trust policy for AWS rather than local stack. Now we're just repeating everything on AWS just as we performed it on local stack. And when we have everything set up for IAM on AWS, we will go and put all the relevant artifacts into Crypto Manager to run the STS Credentials check. So we create the credentials, and just as before, once we've created these encrypted credentials, we copy them into Crypto Manager. When we have the role arm and the credentials set up in Crypto Manager, we will be able to create our STS session. Then we obtain our STS credentials. So there's our credentials and our token. We're ready to run the test against AWS. And this should list all the buckets we have on AWS. Just make this a bit bigger so we can see there's all our buckets on AWS. So our credentials test worked out.